Welcome back. In this teaching video, I'm looking at 4.1 moments. 4.1 represents Chapter 4, Section 1 of the Pearson A-Level Maths Applied Maths Year 2 textbook. Let's go through the key facts of this section. Firstly, what does the moment of a force measure? Ladies and gents, the moment of a force measures the turning effect of the force on a rigid body. How do we calculate the moment of a force? Well, the moment of a force is given by the force itself multiplied by the perpendicular distance. The unit that we use for moments is Newton meter. Consider the following right angle triangle. Suppose this angle is theta and the hypotenuse is d. This side has the 90 degree and the theta, so it's called the adjacent. The adjacent is given by d cos theta. This side is called the opposite. The opposite is given by d sine theta. These are the key facts of 4.1 moments. I'll be implementing these key facts within examples and then an exam style question. Let's have a look at an example. Calculate the moment about P of each of these forces acting on a lamina. Part A. So here is the lamina, that's the fixed point P, here is the force 3 newtons. So we have that the moment of 3 Newton force about P is equal the force itself, which is 3 newtons, multiplied by the perpendicular distance from the point P to the force 3 newtons. So that perpendicular distance is 2 meter. So 3 multiplied by 2, this is 6 Newton meter. We need to specify a direction. Suppose I hold on to the point P. If I hold on to the point P and I apply this force 3 newtons, it's going to take the entire lamina clockwise. So the direction is 6 Newton meter going clockwise. Let's have a look at part B. So we've got the 20 Newton force. Here is the lamina. Here is the fixed point P. We want the moment of 20 Newton force about the fixed point P. This will equal the force itself, which is 20, multiplied by the perpendicular distance from the point P to the force. That perpendicular distance is this distance over here. We've got a right angle triangle. This side is the opposite. So that opposite will be of the form 4 sine 75 degrees. Okay, so the perpendicular distance is 4 sine 75 degrees. We can now put this into our calculator, and if we do this, we end up with 77.3 Newton meter to 3 significant figures. Suppose I hold the point P and I apply the 20 Newton force. This is going to take the entire lamina anti-clockwise. So the direction in this scenario is 77.3 Newton meter going anti-clockwise. Let's have a look at part C. Here is the force 9.5 newtons. Here is the lamina. Here is the fixed point P. We want to calculate the moment of 9.5 Newton force about P. This is going to equal the force itself, 9.5 newtons, multiplied by the perpendicular distance from the point P to the force. That is this perpendicular distance. Now we've got a right angle triangle. This represents the adjacent because it's got the right angle and the 60 degrees. So that side is calculated by taking 2.8 cos 60 degrees. So the perpendicular distance is 2.8 cos 60 degrees. Hence, the moment of 9.5 Newton force about P is equal 9.5 multiplied by this perpendicular distance. So if I put this into my calculator, I get 13.3 Newton meter to 3 significant figures. Again, I need to specify a direction. So if I hold the point P and I apply this force, it's going to take the entire lamina clockwise. So we've got 13.3 Newton meter going clockwise. That there, ladies and gents, completes my example. Moving on to an exam style question. In the diagram, the force F Newton produces a moment of 15 Newton meter clockwise about the point P. Calculate the magnitude of F Newtons. Ladies and gents, firstly, we know that the moment of F Newton force about the point P is given by 15 Newton meter. So I'm going to be using that result to generate an equation involving F. So we've got the force F. We want the perpendicular distance from the point P to the force F. So we can drop a perpendicular distance as follows. This is your right angle. So we've got a right angle triangle. This side here represents the opposite. So that opposite is given by 12 sine 30 degrees. So the moment of F Newton force about the point P is given by the force F itself multiplied by the perpendicular distance from the point P to the force F, which is 12 sine 30. This must equal 15. Now I can rearrange to make F the subject. So F is equal to 15 divided by 12 sine 30 degrees. So F is equal to, if I put this into my calculator, I get exactly 2.5 newtons. This completes the exam style question and this teaching video 4.1 moments. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.